Thank you. First of all, thank you so much for accepting my invite and thanks for taking out time on one of the data modeling. I never heard about it and I intentionally did not open Google to research because it'll be fun to learn something from scratch from you and let's see how it can go because I'll be very blank what this FCO-IM data modeling is.
Okay.
So before we jump into Marco, we would like to know about you because even offline we never had a chance to catch up. This is the first time, and for our audience as well. I still haven't got a lot of audience, but still for my audience, please can you introduce yourself?
Well, you at least have a good lineup of speakers, so I feel honored that you invited me.
Hmm.
Yeah, start with me. I'm getting at the age that I've been in IT for many decades, so I see things come back in fashion again. So it's like, when
True.
I started IT, I had seniors around me who said similar things at the time, and now I'm becoming this senior that sees things reoccurring. I
Just
started
like fashion. Yeah.
like fashion, yes, very, very much. I always had a passion to make software, and that started at the early age of 13, 14. Now, nowadays, kids grow up with computers. It's common for
Mm.
young kids to get them interested in there. When I was a kid, that was a rarity, let's put it that way. And So I always tried to make software for computer users and just go a little beyond what they wanted or expected, and that got me into this career of making custom software for startups, companies, decision support, cash flow management, and all kinds of different products that we had out there. And early 2000, a professor knocked on our door and said, "Well, we have this bunch of source code, and we need a company to support it properly and develop it further." So for the past a little over 20 years, I've been developing this case tool that supports FCO-IM. Um,
Okay. So I
and
got the right person. Got 20 years in FCO.
yeah, yeah. So I can explain a little bit about FCO-IM and where it came from, and what it beholds. Um, I can give away what FCO-IM stands for. That's always a good starter,
Yes.
because it sounds like
For
so many
me,
acronyms.
it looked like fact something. I didn't go further, but it
The
looked
fact
like facts.
the fact is good. The fact is good. It stands for fully communication-oriented information modeling.
Ah, fully communication information modeling. Okay, that makes sense.
Communication oriented. So that's
Oriented.
it's if you look it up, it's FCOIM hyphen
Yeah, I am.
FCO hyphen IM.
Yeah.
And and the research for this stuff started late 60s, early 70s in the Netherlands.
Wow. It's older than you're saying everything.
It's
Even
it's not
3
older than
billion
me, so
months.
um,
Now, okay,
but
let me set the stage first because this
yeah,
is going to be very exciting for me as well
okay,
and for our audience as well. Let me set the stage because when you said 1960s, you have bypassed the era of, you have gone before Bill and Mon, who has come up with the first data warehousing. We all call him father of data warehousing. So
yeah,
he came up with this 3NF warehousing, and then Kimball came in with dimensional, and then this data vault came in 2000s. Then
yeah,
around the same time, Focal came in. Then Anchor came in. They start calling it assemble data modeling, right? And now you're saying, so they are talking about 2000. Now you're saying 60s. So where does, so I've said the context already that there are so many data modeling there. We consider Bill and Mon 3NF and dimensional for Kimball as batch. I normally call it batch and waterfall data modeling,
Yeah,
and data vault, focal, and anchor. I put it into a what do you call it? Agile data modeling. So
yeah.
now this FCO-IM come. Okay. Now let's jump into what is this? 60s. Wow. Okay. Let's jump into it.
Uh, yeah. So you guessed the F was for facts, and
Mm.
to make a clear distinction, because many people that hear facts think, oh, facts and dimensions, coming from a
Okay.
data warehouse background. Um, it's slightly different in a way that the fact-oriented modeling approaches really try to focus about statements that we can agree upon as being true.
Hmm.
So it's a synonym, but it means something else from the modeling part.
Okay.
And a fact could be Mustafa and Marco are having a podcast.
Yeah. Is a
Mustafa
fact.
agrees, I agree, we agree, that is a fact. And it goes a little further beyond that, because it ties in with our natural language. So how do we talk about our data? And so we basically do quote, Mustafa has a podcast and has Marco as a speaker,
Hmm.
unquote. Or so with that, we stay very close to the natural language as we speak it as humans, and basically, like elementary school, we start classifying parts of that expression, like, this is the subject, and this is the object, and this is the verbiage. And by doing that, you start dissecting the grammar of it. You start recognizing, wait a minute, there are nouns in there, there are verbs in there, and the nouns actually represent things that we talk about.
Yeah. Entities. Yeah.
And I'm giving you the simplest explanation of it.
No,
So
we need that. We need that. Yeah.
and so, given that fact expression, one would analyze, okay, there's a name Mustafa, there's a name Marco in there, but those are people or persons. And so we initially you classify that as this is a person, and we use the first name in this case as an identifier for the person. And the identifier is then, those are the first names. So we constructed basically a piece of grammar that starts with an expression, a fact expression in this case, in which we have identified person, and we have identified that we use the first name to identify this person.
Hmm.
And that builds an information model. So there, in the whole approach of FCO-IM, and let me repeat the acronym, it's fully communication oriented.
Okay.
So instead of looking at, we have data and how is it structured, we focus more on how do we even talk amongst each other, sharing information and sharing data.
Okay.
So it's a slightly different focus than traditionally is used in IT.
Can I add, does this thing has anything to do with NLP and text analytics, which Bill Inmon is building nowadays?
Not directly, but interestingly enough, if you search for if you start looking for the background, a theoretical background for NLP, you will end up in the same era.
Yeah.
Because in the 70s and early 60s, there was a lot of theoretical research on what are we doing, how does grammar work, how does translation work. I mean, even I don't know if you're a fan, but the TV series for Star Trek, for instance.
Yeah, of course.
I mean, they have Klingons in there, but it's like they actually, by the making of those series, they actually developed a Klingon language with full grammar So there's a lot of research that dates all the way back to those eras of how does that work theoretically. So NLP has its roots there. FCO-IM leans on it just a little, but not. It doesn't try to get into the depth of the linguistical parts of it, because that's becomes incredibly difficult already. So it touches it and it rests on it, but it doesn't go into the depth of it.
Okay.
So it would suffice for me to say, Marco and Mustafa are in this podcast, without going into what is the verb, what is the root form of this verb, and so that's the whole linguistic part. With FCO-IM, we're only interested in using that natural language to identify the objects and the data labels, if you will.
Okay.
So it touches that, but it doesn't go into how does the verb work, or how does it change form, if it's plural or past tense, or it doesn't really care for that.
Oh, it just pickups, like in one of the NLP recognition, when you do it, it also goes and pick up this. Okay, I'm referring towards the LLM world as well, because LLM world go and
Yeah,
touches NLP, and within the text, it pick up the nouns, it pick up the
right,
verbs, it pick up the
right.
adjectives,
Yeah,
and then it creates joins. I think we can, because we are going very technical, we can go towards ontologies as well. So nodes and relationship, it creates based on that.
right.
So yeah, and it does check whether it's present, past, and future tense based on that.
Yeah,
And then nouns and acronyms, all those things it picks up and then creates something uh,
wonderful stuff. Yeah,
context, right?
yeah,
So
yeah.
you are saying FCO doesn't go in detail at that much. It does check.
No, but
Yeah.
right. If you're modeling with FCO-IM, you basically say, if I have the fact statement, but then it's at the top level, it says person is in the podcast of person.
Yeah.
That's sufficient to build an information model.
Absolutely. Then it can be most. So today is Marco. Yesterday is what Bill in month. Then it was Chris.
Right. Yeah.
So you have
Yeah.
picked up the entity
Right.
and
And
you
then
attached. Yeah.
yeah. And as soon as you populate it with more examples, more data, you get all the different names that are in the podcast, and all of those populated statements are then the facts.
Oh, so it means we
So
are.
Bill is in the
Yeah.
podcast of Mustafa. Marco is in the podcast of Mustafa. So those two are facts.
Okay. So can I go further towards knowledge graph? Because what we are saying is we are creating these graph theories, and
Yes.
within graph theories, we are throwing the data inside, and which graph becomes knowledge graphs. So
Right.
are you
Magically.
referring? Are you referring this graph theory?
Well, okay.
How
So
near you are graph theory to the graph theory?
so the interesting part is that if you study graphs, you will start realizing that everything is a graph.
Absolutely.
Um,
Absolutely.
if the issue is that the graph is a theory on how you can connect edges and nodes.
Yes.
It doesn't really give you a method on how to approach this.
How to approach this? Okay.
So where do I find the person? Where do I find the first name? Where do I find that they're in the podcast? So it doesn't give you a stepwise plan on how to build a graph model. It just says you can build it. Good luck with it. And then you're on your own. It's like, okay, what do I think the graph is?
Okay. It's getting very interesting, because there is, to start for a project. Sorry to stop you, because this is going
Yeah.
very interesting, and this will become one of the best podcasts actually. Because we both of us are talking very tech things. We are just simply throwing here and there, right?
It will get clear as we move forward. Yeah.
See, so now we are talking about starting from information product canvas. where we do it's a problem solved by one of the guy in New Zealand,
Yep.
Shane Gibson,
Yep.
and he has come up with this information product canvas where he has 12 areas. So he starts with that if you want to create a product, then you need to have questions, that what questions you need to ask from a product.
Right.
Questions has to have an answer. So a business should already know that he wanted to ask some question and this is what he want to get the answer. And based on the answer, one should be able to have an action. So I converted that 12 into 4 actually. I call it 4 pillars, 4 dimensions. How you have questions, you have answers, you have actions, and you have value add, right? So now when you ask question, you have answers, then you create user stories.
Yep.
This is all simple English.
Yep.
So from there, he goes toward that. After that, you can end up creating models. I say no. After this, I want to create graphs. I want to go towards graph theory because
Mm-hmm.
once I have question, answers, actions, and value, based on that, I create user stories. Based on that, because within the user stories, I can dig out entities, I can dig out relationships, I can dig out nodes and all those things, and I create a graph theory.
Yep.
Now, interesting part what you're saying is because those questions and user stories are something which FCO-IM, what I am foreseeing, this is what you pick up.
Yep.
And then, okay, now let's go next step. Are you saying that those questions are your FCO-IM will help to read those texts and convert into graphs? Are you saying that?
Well, if you look at some of the diagrams of FCO-IM, because it's text input and text output, but the storage is you can look at it as a graph.
Okay.
Interestingly enough, the tools actually store all that in a normalized database, so it doesn't even use a graph database at all.
Which is fine.
So there's it's a very nebulous terrain. So I to make some comparison, the graph that basically says I have edges and nodes.
Yes.
And nodes being the things and the edges being the connections.
Hmm. Yeah.
In a way, it is so. Those are so fundamentally building blocks that you could compare it with assembler in programming.
Okay.
Now the hard part is that we don't want to stay at that level because it's too cumbersome, it's too laborsome, it's too many details. So you want, similar to you want a higher level programming language,
Hmm.
be it C, Python, Pascal, PHP, whatever. You don't want to revert back to the assembler underneath. That's
Hmm.
insane.
Hmm.
So you want to move up to a more effective language that we can program with.
Okay.
And one of those things is relational modeling.
Yeah.
Or like we do with FCO-IM is we use the fact-oriented approach. We use natural language and we find the nodes and the edges in that communication. The underlying could still be perceived as a graph, but it's similar to any programming language can be perceived as assembler with instructions for the CPU, but that's not really the level we want to communicate with.
Mm-hmm.
We want to have a higher level way of approaching this. FCO-IM is such a higher level. Once you've done modeling, you can then generate a graph very easily because it has embedded underneath, like assembler in programming languages, it has the graph underneath it. Everything is connected with everything.
Hmm.
If you do relational modeling, you have tables and columns and foreign keys. You can still
Yeah.
perceive that as a graph.
Yes, but in relation modeling, you always have only one relationship, and that is also embedded in primary key and foreign key. You
With
can have
every right, with every programming paradigm, it comes with restrictions and a different set of building blocks. In relational modeling, you have a table, you have columns, you have primary key, you have alternate key, and you have foreign key relationships, and that's it.
Yep, that's it.
With graph, you have two. You have edges and nodes.
Yes.
With FCO-IM, you have three. You have fact types, you have object types, and label types.
Okay.
So every paradigm comes with its own sets of types. In UML, you have classes and properties and relationships. You can have stereotypes. So stepping away from the graph, because everything can be perceived as a graph.
Yeah.
Which means that in the graph, you can both represent the relational schema. In the graph, you can represent an FCO-IM model. In the graph, you can represent a UML class diagram. That is not the problem. The problem is that how do you build this graph? This same question is, if you want to do a normalized model, where do the entities come from?
It comes from there. Yeah.
If you do UML class diagramming, where do the classes come from? So the interesting part of that is, and for the most part, because there is no method to this madness, right? And let me elaborate. We're talking about podcast, and you are the host, and we have guests. So I could, in my mind, I could instantly make a table with all the people. Okay, so it has a relationship with the table of hosts, and it has an attribute maybe with the title of the podcast and the date it was recorded. But I'm doing that up here. Okay. I'm doing that here, and I'm doing that based on my assumptions. This is what I think I understand of this domain of podcasts. Now, I'm not a professional podcaster, so I make assumptions. Now, here's the trick. If you scale that up to, for instance, a medical domain, where you have to build an IT system for the intensive care of a hospital, are you still confident that your assumptions are correct?
High risk.
High risk, right. So how do you make sure you get the right terminology? How do you make sure you get the right object types or tables or classes? How do you make sure that the relationships are correct? How do you make sure that it has the right set of columns and properties? And if you're going to do it in any of those traditions or professions, and let's include graph. Okay, I'm building a graph. How are you going to make sure that it is the right graph? How are you going to make sure that it's the right database? And how are you going to make sure it's the right piece of software? The only way to do that is to not do it up here, but to actually communicate with the business that need an IT system supporting their profession. Now, if I'm working to build an IT product for a medical or railway or whatever domain, could be a chemical industry, a trading company, it doesn't really matter. It's not my expertise. So I have to find a way to communicate with the business on how they do their business. I need to find a way on how to get inside their heads to figure out how they talk about their work and how they talk about the information that they need to do the work. And I need to figure out how departments, employees communicate amongst each other in their own words and language, how they exchange information and data so that they all understand and they're all on the same page.
Agree on that.
And what I took away from software modeling classes and relational modeling, logical modeling, you name it, is they all tell you this is how you draw a picture. But it doesn't explain how you get from the business communication about the information needs to the picture.
Hmm.
And for that, you need a method. For that, you need a stepwise plan that says, if you follow these steps, you will be 80–90% sure that you did the work correctly.
Hmm.
And so my mission, if you will, with FCO-IM is to continue that awareness that, and luckily you see it more and more with the increase of LLM, AIs, NLP, graphs, and you name it, software development, database development. They all realize that they're all at the edge of the ravine and say, you know, we're doing all this tech, but we need to figure out how to talk to the business.
Yeah, yeah. So let me throw one thing here.
Yeah.
Are we saying that because the basic level which you are talking about, that really help us to create OLTP applications? For example, a business starts and you understand what their business is, and based on that, you create a data model, right? So are we saying that FCO can or FCO-IM can also be used to create OLTP application as well as OLAP as well? Where
Yeah.
this modeling helps? Both places, one place where?
It can do that because as soon as you understand how information is related to each other, you can then start adding transformation rules.
Hmm. Yeah.
So if you build an FCO-IM model and you know, and let's just stick with one domain and one language.
Hmm.
To do a normalized OLTP database, you need to figure out what are the rules on this data. And you will see that depending on what the business says, you know, a podcast is always a one-on-one relationship. It
Hmm.
will steer the model transformation rules into how the database schema should be.
Hmm.
But it's interesting because it's first of all, it starts with an information model, but only by adding the constraints
Hmm.
you can then derive a data model.
So it means this is not a physical data model. We design it on paper or on drawings. It's not something we go and implement. Based on this, we can implement OLTP applications, we can implement OLAP,
Yeah, yeah,
any model based on this data
yeah,
model, which is on the paper.
yeah,
Correct?
yeah.
Uh, and
And
graph, it means graph theory or knowledge graphs can also be built on this one. So this is, now I'm seeing this onto Wikipedia, some
yeah,
diagrams. I can, so there's an example of student, right? Student is a city of residence and the city. So
right,
student has first name, last name, and it
right,
can relationship is a city of residence, which can be New York
right,
and lives in. So I can see both relationships here and in a city.
right.
Yeah.
And
So
then you add the constraints because he can only live in one city at a time, or can he live in
yeah,
multiple cities? So and he's just
yeah.
moving from his student dorm to his, you know, home back like his parents, or so the constraints on it is it results in I have a student table with a column for the city,
Hmm.
or I have a many-to-many relationship and I need something completely different.
Mm, mm, mm.
But if I look at it from a graph theory, sure, there's a relationship and I have a city of residence and all is good and it's all connected.
Yeah.
The distinction is that even though you can see how the underlying graph would be,
Hmm.
is if you do that by making assumptions about the domain, you have no way to verify it. It is your perception that is manifesting in a graph structure. And as with I experienced with my wife, she's from a different country, and we had to figure out what is the common English that we speak. Okay. So, and here lies the problem. We both come from our own world, and we're an expert in our own world. Many IT people are an expert in IT. Many business people are an expert in business.
Yeah.
And here starts the communication problem, is that as soon as I start assuming, you know, this person starts talking, starts explaining, and I'm like, oh, I think I understand, and I start building it.
It's not true. Yeah.
But the thing, and here's the thing, you know, somebody with decades of experience in their profession will not be able to explain more than 20% in an interview.
True.
But me, as a listener, I have to be very careful to not think, I think I heard 80%. And this is where the miscommunication starts. Now, imagine I'm building a graph based on those assumptions. Suppose I design a database based on those assumptions. Suppose I built software in an agile way, and I go back with the minimal viable product and say, this is what I've got. What will be the reply? Well, usually that's not what I meant.
Yeah.
Okay. So what happens, and I talked with modelers and architects and business analysts, and when I did explain to them what FCO-IM is and how it's tool supported, they all understand immediately, oh, this is what I do in my head.
Yeah.
Yes. And there's the thing. You listen, you assume, you design, you build, and then you check back if that was what was intended.
Yeah.
To make it more complex, the business is sometimes an expert and cannot explain anymore what they know.
Correct. I agree.
Okay. You know, we have in our language we have the male and female articles for nouns. And in learning the Dutch language, my wife said, so when is it male and when is it female? And I'm like, I make no mistake with it, but I cannot explain it. Okay. Now, can you imagine? You built this system for the medical department, intensive care, and you're talking with a surgeon with 40 years of experience. He will not be able to explain why things are the way they are.
Yeah, true.
And yet we have to build a system.
Yes.
So, and we cannot rely on assuming and doing it up here and then sketching out how it should look. We cannot draw a table with a line to another table and expect that to be verified. I've been in conferences with dozens of data modelers, and I showed them a logical diagram. And I asked the audience, and this was a very simple, 4, 5 tables at the most. I said, who can vouch for this model? Nobody raised their finger. And so I asked, why? Because you're all experts. Do you not understand what this diagram says? And they all, without exception, said, but we're missing the story.
Yeah.
We don't know the story of the business to be able to verify this. So it all ties back to, okay, but how do we verify the story? Well, you have to go back. And I'm sorry to say you have to figure out how do the people in the business communicate? How do they talk? And it's that is just the start, because and you will recognize the examples immediately as I call them. We have a term called inventory.
Yeah.
Now, we all know what inventory is. That's how much stuff you have, right? We have a good definition. We're selling books, and yeah, it's the amount of books that we have in supply. Right. Okay, cool. Let's write that down. And but then once it's built, what happens is the different departments are looking at the reports, and it's like, it doesn't add up. The numbers don't make sense. So what happens? Well, you know, we have sales that said, well, I already sold them, so you know, you have
I
to subtract that.
I was about to introduce a word of interoperability. The
Well, you
people,
know,
the
yeah.
reason those guys did not raise their hand, because this interoperability is an issue in relation model, right? You do not know which kind of data is sitting, coming from where, and
Oh,
is what, right?
right. Then, of course, you know, they have the purchase department that already ordered a new batch of books, so they add it to the inventory.
Hmm.
And then you have the guy in the warehouse that looks at the shelf and says, well, I only have 3.
Yeah.
So it's not sufficient. It's insufficient to be talking about business definitions or terms, and it's not sufficient to be talking about data structures at a type level. It's not sufficient to just build structures. You have to verify the language. How do we talk about it? Well, we have this book, and it's identified by an ISBN number or our internal article number, and we have 3 on a shelf. And you go to a different department and they say, well, no, we don't have a shelf, and we don't have 3. So by actually looking at the concrete examples in those facts, you get to an additional layer of verifying if you understood the domain. Now, and here comes logical modeling. It's like, oh, we got tables with columns. Yeah, I think we got it. Yeah, we got articles and we have an amount of inventory. Yeah, we're good. There's no verification.
No.
There's no cross-department, cross-system, cross-domain verification if this is correct. And that you call it the interoperability. It's the interoperability is a problem if there's no communication pipeline through the business.
Correct.
And this is one of the phenomena that I see in large enterprises too. It's like departments want a solution for their work. So they build a system to fill that quest within that little scope. And then it doesn't align with anything else.
Yep.
So, you know, even building a very solid model for a solution, a database, a system is not sufficient. You not only have to verify, did I understand their communication and their business on all the levels that I just expressed, but also, does it tie in with the communication of the other department? So it's a very, very laborious effort to do things right. And you can see how the communication ties it all together. And the verification of that communication needs to be done to make sure that whatever data product we built, or whatever data product or we try to integrate from various source systems, if we do not align it with the communication of the business at one point, early or later, then we're only looking at technical data and we're never sure, because it's all built on assumptions for a specific business user or a specific business problem domain. So here lies my challenge with FCO-IM and bringing that to everybody's awareness and attention. It's like, we can build a lot of tech, but in the end, it needs to serve the business.
Yeah.
And the interesting part is that we listen to the business of what they want, Then we throw away the story. We build something technical. And then when we need to have data warehouses and data lakes and dashboards and KPIs, we have to figure out what the story was because it's gone.
Yeah.
And graph is a great technology. LLMs are wonderful, but we're missing the story of the business itself.
That is where I can see this is coming actually. And let me add a hard question here. Then why this is not very famous? Yeah.
It's an interesting anecdote, right? So you have to, in a way, if you look back at history, this is interesting. And this is anecdotal. I'm not sure if that's true or myth. Logical modeling was easier to print on paper because it was all squares and rectangulars and lines.
So it was very many relationships. That's all. Finish.
Yeah, but it's still on a character based. I mean, if you go back to ASCII art, if you will.
Yeah.
A logical diagram can be made out of hyphens and pipes and pluses and minuses. That's the era where these they didn't have graphical printers, decades ago, but this could be printed on paper. And at the same time, drawing by hand how graphs work with circles, and circles don't print well.
No.
So I think in trendy and being hype in the 70s, I think logical modeling won the market because it could print squares.
So we are saying from user requirement towards the logical model, in between comes this FCO-IM. Right. Did I catch it correct?
Yes. And and that's the beauty of that, is that you with that you add a lot of metadata. I not only write down your concrete examples and your language and your example and your fact expressions, I also write down that Mustafa said this. I also, with every expression, I write down it was Mustafa, it was on this date, and it was for this department and for this purpose, and I was the modeler, and it was verified by and approved by, and it's implemented in system such and such. So on a very detailed level, you get verification and application and lineage on where it came from. And then you can pick and choose, I want this fact and I want that fact and I need this fact. So you can pick and choose on a very elementary level, what do you need for your solution? Well, I need this one and this one and this one.
So isn't it graph theory? Because what I'm hearing is that FCO-IM is graph theory. It's not graph. See, graph is a next level. Graph theory where you define. So I can see this is a graph theory.
Yes.
Based on graph theory, you end up creating OLTP, OLAP, data vault, or graphs as well.
Yes.
I can we declare this as a graph theory? Because as I mentioned, from information product canvas, I want to build a graph theory, and based on graph theory, where there is all this, what you're saying here is there on the board, and we show to business that this is what you want and this is what your reality is. When they say yes, then we will map, hey, your question can be answered from these two names or entities or concept, and this is the relationship. And for example, there are 5-6 connections and many relationships, and you say, hey, these relationships, which kind of data quality you want? So I'm bringing data quality into it as well, because data quality at a wholesome is never a sellable item. So data quality differs on every relationship. There has to be score. Then we listen to them. We create this graph theory, which is FCO-IM. And based on that, we say, hey, out of all these, you ask me to create a product, but I can see out of this, I
Yeah.
can pick up three entities, two relationship, and I can build a dashboard for you, which can generate 50% of your revenue. Shall we do it in next 2 weeks? Of course, they will say yes. So that is where I can break down from this. Now I call it graph theory. It's a FCIM.
Yeah.
Because this, see, the second example I am seeing over here is a little bit more complicated, and this gives me a great output of student city, you know,
Of course. Yeah.
apprenticeship city, and all. This is absolutely graph theory, actually.
Of course. I mean, of course, graphs is one of the outputs of FCO-IM.
So it's FCU. I am is a graph theory model, and based on that, we create graphs and we can create anything. Awesome. Now I really understand. Now going back onto the at a very theoretical level, like
Yeah.
Data Vault has this hubs, satellites, and links,
Yeah.
and kind separate.
Yeah.
Can you elaborate quickly, theoretically or for student level, what are the elements in FCIM? Like in relation, we have tables, columns, we have
Yeah.
primary key, foreign key, we have indexes, blah 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 blah. Everything have the star schema. We have facts and dimension. What components we are looking here?
Well, you on the other screen you have the FCO-IM page of Wikipedia, right?
Yes.
So since we're just doing a person-to-person podcast, it's a little hard to visualize. But if listeners open up that page, they will be able to relate to what I'm saying. Okay.
Yeah.
As I started with it, the FCO-IM approach starts with: do we have consensus about the fact statements?
Awesome. Yeah.
So Marco lives in the Netherlands would be a fact statement, and there are multiple Marcos. So if the data domain becomes too big, Marco will not be sufficient. But let's keep it small for now.
Yeah.
So Marco lives in the Netherlands, which is a fact statement. Now that statement expresses a certain type. So Marco lives in the Netherlands is considered the homeland. So all statements in that regard are of the same type.
Okay.
So Bill lives in the United States, Marco lives in the Netherlands. They're all facts of the type homeland.
Type homeland. Okay.
Yeah, or motherland, or just
Yeah.
whatever we want to,
Yeah.
depending on the business domain.
Yeah. I'm with you. Yeah.
So that's your starting point. And then you introduce these so-called fact types. So the homeland is a fact type. Now, within the fact type, I find new things. Let's call it things for now. I find Marco, I find Bill, and I find the Netherlands, and I find the United States. Now, these are representations of things that we perceive in reality. Marco is a person. So we write down Marco as an object type.
Object type. Okay.
We write down the United States and the Netherlands as the country. The country is an object type.
Okay.
Now I'm talking about object types, and then within those representations of things in the real world, we look at, okay, and what's the data in there? Well, within the object type of person, we have the first name. The first name being Marco, or the first name being Bill. Now, this first name is actually what we call the label types. Technically, you would store it as a varchar 64, but that doesn't mean anything to the business.
No.
What it means to the business is those are similar data types, and we name them according to business terminology. So we call it the first name, even though we're storing it as a varchar.
Yeah.
right? So
Yes.
those are the label types.
Label types. Okay. Object types and label types. Okay.
Similarly, on the country side, where we have country, but we don't store countries in our database. We store country names in our database.
True.
Right? So the country is a representation of what we perceive as a thing, and then the Netherlands is the name of the country, the United States is the name of the country. And then the name of the country itself becomes that label type, which is then also some type of varchar in a database.
Yeah.
Or string in JSON, or whatever you want as a technical data type. So I broke it down to three things, if you will, in FCO-IM. Underlying that was the semantics, the language. Underneath that was also the examples. I'm actually storing Marco and I'm storing the Netherlands in the model. And this might be interesting because where we have the homeland as a fact type, we can now say, well, Marco emigrated to Belgium on the 1st of January. So what we're now doing is we're using the fact of homeland, but now we're using it in an expression as a thing. Okay, because the homeland changed per a certain date. So we now introduce a new fact type. We say Marco emigrated to Belgium on the 1st of January, which is not true, but let's just...
example.
We have good fries in the Netherlands too. I don't need to move to Belgium. So I introduce a new fact, but in recognizing the things Marco emigrated to Belgium, that's the homeland. It's a new state, but it's still the homeland. So now the homeland, which was previously just a fact type, now becomes an object type as well. So you see how object types like person or country or homeland is underneath also a fact type. It's just repackaging it in a different expression.
So we have fact type, we have object type, then we have object
types.
labels, right?
Yeah.
So these three hierarchies, okay.
And this can become more and more complicated, because if we're doing a student's administration system, and I'm just keeping things simple, I would have Marco lives in Utrecht, which is the city I live in, but Marco is a student. But wait a minute, all students are people. So student now is a subtype of person, and the person is identified by the first name. So with the city of residence as a fact type, now I discovered that Marco was the student, which is an object type. And students are identified by persons, which is also an object type, which are identified by the first name, which becomes the label type. So within a simple fact expression, like Marco lives in Utrecht, you don't really see the depth of things. You have to talk to the business and say, okay, are we talking students? Are we talking persons? Are we talking civilians? What does Marco mean? What is it? Is it a customer? Is it a teacher? So by having that communication going with the business, you can start asking questions.
Which has to be domain specific. Yes.
And you write it all down in natural language. So you start with those fact expressions coming from the business, and then you do the analysis on it with the business. So you can see that from that exchange with the domain expert, you will find different object types within the same fact expression. Because they are the only ones that know that there is more knowledge that they haven't told you.
Yeah.
On the surface, we might look at it and say, okay, that's if I make a person table, I'm good. Yeah, but it might be something completely different.
So can we say that once we start creating this FCO-IM, which is a graph theory for an organization,
Yeah,
so by right, in an organization, let's take this, let's say you have created for a banking system for a bank,
yeah,
you have created FCO-IM for the whole bank.
wow, yeah,
Will that remain same for all other banks with some customization because it's a domain specific? You have created an FCO-IM. Is it okay? How to put this question? What I'm trying to say is once you created once,
yeah.
you don't have to create again. It's a one-time creation because it's a business. Is it true?
Um, yes and no. You mentioned banking. You're probably aware that IBM has a banking model.
I'm coming there because that is
Well, that's
that's
yeah,
something like financial communication model, all those things, right?
right.
Telco
But
has their own model, and finance has their own model,
right.
right? But I think,
I still have to find a bank that
mhm.
purchased the IBM banking model and actually implemented it one on one.
See, that is where I'm coming because those models are specific to a problem statement,
Yep.
or if not a problem statement, or a department or subject areas specific, not at a bank, right?
Yeah.
Because
That's
you're buying a solution, right? It cannot have
right.
everything. It will,
No,
yeah, right. It won't
no.
have everything, right?
Right,
Uh, if you go into a banking, let's say, loan is a different domain,
right,
insurance is a different domain,
right,
and if you go towards finance is a different domain, marketing is a different, sales are different.
right, right.
So all these cannot be built by one data model. There will be separate data models,
Yes,
right? But when you
yes.
go toward FCO, FCO, I think, is a holistic understanding of all these entities and relationships, everything. Is my understanding correct? You create one FCO model for the whole organization, one in a lifetime.
Well,
Enhancements will keep coming, of course. New functions will
no, no.
come.
It's. I mean, it's. I agree that there's a tendency of if that would be possible, that would be great.
Hmm.
Yet, what I've seen is, for instance, in the Netherlands a couple of years back, I was coaching a head office of a daycare center.
Hmm.
They were into this FCO-IM because they had so many systems. They had to harmonize all of that. Because what happened is that over the lifetime of this company, they had maybe 40 mergers.
Ah,
So they
this would really
purchased
help.
another daycare center and another one and another one. Okay, so
Yeah.
here is it. It's like all the departments that you could track down to where they came from originally had a different way of talking about data.
Absolutely. Absolutely.
And they found that they had an issue with a term called location.
Ah,
Now, was it the zip code? Was it the office where the parents would register their children? Or was it the shed that the maintenance guy needed to fix the roof? Or
yeah.
was it the location in the financial accounting system on where it needed to go in the booking?
Yeah.
So, and then, and this is the interesting, if I would have had a model for a daycare center,
Hmm.
it would not have served them because they would have a different communication.
Hmm.
So similar with the banking model, you buy it and then you have to check, does our business even align with that model?
Align with that. You have to customize all the time. And
So
customization is
and
takes a lot of time.
it's because it would be interesting if all car manufacturers work in the same way, but they don't.
They don't.
All smartphone producers work in the same way. They don't.
But having said that, but 80% of their models are same. Okay, let me squeeze that question. In a bank,
Yeah.
you have a sales domain.
Right.
If you, okay, sales domain is a little bit tricky. Let's say finance, because finance is finance. Once you start creating this FCO-IM for finance, it remains as is 95%, right?
Maybe.
Because finance doesn't change, right? Finance is finance.
Yeah, fine. Yeah, true.
HR remains same. Right? Once you define employees, staff, contract staff, employees, once you have this graph theory, it doesn't change unless you now already vendors, so it will remain same.
No. But that's a good topic. That's a good topic because what it it's you're looking, if you perceive the world like that, it's very static. One model should fit 80% of all needs. But if your organization has culture, it doesn't apply. If I and I peeked with into an international organization that said we need to unify our systems. Great. But they have customers in different countries, over 100 countries. All those countries have different rules. So when you think, for instance, very simple, okay, this is the zip code, it doesn't work. Every country has different zip codes. When we want to address our customers with dear sir or dear madam, in some countries that is illegal. So the perception of this is how we communicate is very much biased from what we know. And even if it would fit 80% of what we need in our company, the question arises that how do we verify that it is 80%? How do we make sure that this is actually fitting for 80%? How do we make sure that that 80% is actually accurate? We still need to go out and check.
Talk to business, lah. Yes. So one time you have to talk to business. So having the same example, like for sales domain in a bank, you create this FCO-IM, which is again before logical model. It's not an actual physical model. It's a before logical model. It's an information model. In other words,
I would love to see that happen. Yes, of course.
So once
I have factual statements, and all you have to do is check mark yes, yes, no, no, yes.
Now you take this FCO-IM to another bank.
Right.
So you should start showing them.
It should be a checklist. Yeah.
It should be a checklist. At least 90% will be a checklist. Rest they can, based on their business, they can change it.
Yeah.
I think we have cracked this thing.
And I'll make it a little easier for you. If you look at the tool support behind FCO-IM, it actually has a button that says, well, you documented all in Dutch. You made your, a local bank has to abide by the Dutch law on finance, everything. Everything is documented in Dutch. Now we come to the different department of the bank that does international business. Well, the international regulations are a little different. Things are named different rules apply. So as long as you can make the distinction between this is national and this is international, it's fine. But you need to figure out how things relate to different terminology. So what it does, it actually says, you wrote everything down in Dutch. Let's translate that. So it comes with dictionaries that do allow you to not have it in your native language, but also in a different language. And specifically in the Netherlands, we like to service countries abroad because we're a very small country. So we do business with Germany, with France, with Spain, with the US. So it needs to be by default able to cross the border.
Agree. So the moment you local goes to international, you just need to add an objects for international one country, then rest country will follow, right?
Hopefully, yeah. But the rules are different too, so it's a little more complicated.
Rules are different. But again, when you goes to a rule, for example, GDPR, right? In Malaysia, we have PDPR, but
Yeah.
GDPR is used across. So it covers 80 or 90%.
Yeah.
So then local laws comes. I think we have a time check. We are almost there, 60 minutes. And I think we have cracked this FCO-IM, which is a data model before logical model. That's a takeaway for me. And it's a
Yeah.
graph theory for me, which I'm creating a paper on it. Maybe I'll share with you as well. I'm very happy that I've met you and we have discussed this. And I think we should have a session with Daniel and you as well. It'll be an amazing session because he's a totally metadata guy, graph guy.
Right. I mean, ideas align. That's definitely the case. Technologies are all over the place.
Yeah.
I find it on LinkedIn as well. It's like there's so many discussions about this approach, that approach, but there's very little consensus about. Wait a minute, we're using the same fundamental principles here,
Yes.
and I think graph can be such a fundamental principle.
Yeah.
I think the challenge is how to build a graph in the first place, how to make sure that the graph is
How to
correct,
create. Yes.
and how to manage the graph over time,
Over time. Yeah.
because we have graphs that render how things are, but now we want a graph on how we want things to be. So in that, the enterprise is so much more complex than just a technology can surface, and
Yeah.
it renders all kinds of management difficulties.
Yeah. Since these AI agents come into picture, right? Actually,
Oh, it's
yeah,
yeah,
I was creating this when I'm creating this paper, right? My idea is to
yeah,
use LLM and whatever AI
yeah,
agents you have. You give it this four pillars, which is question, answer, action, and
yeah,
revenue.
yeah, yeah,
Based on that, you create user stories. Based on user story, now you're telling AI agent to do this. Hey,
yeah,
read these user stories, and we give FCO-IM data model essence to the LLM and say, hey, create this. Once it creates it, and then you ask it, hey, create a data model,
I
right?
totally agree. But I can generate the data model from FCO-IM. That's not the difficulty. The aligning of all those language parts, that
Yeah,
is
yeah, yeah.
that is the trick. That is the trick. Yeah,
Yeah,
but
so
that
so
yeah,
first draft comes out, and then you go
yeah,
and talk to business, and there should be a model. And when you're talking to a business, LLM should be listening. AI agent should be listening. When they are listening, they
yeah.
keep changing the graphs theory for you. It's just a theory. I'm just thinking this loudly.
Well, it's on a tool level, because we've been talking FCO-IM for the major part of this podcast. The tool that supports the FCO-IM is called Kstalk, and it actually integrates the LLM to ask stupid questions. It's
Case
wonderful.
talk. Case talk, is it?
Kstalk, yeah, yeah.
Okay. Let me
It's
explore
as
that
soon
as
as
well.
you. The thing is, if I start asking dumb questions because I really want to understand,
Yeah.
I discredit my reputation.
Yeah.
So what I do in the tool is I do statements, and then the LLM starts hallucinating and starts making really dumb questions, which is great,
Which is great.
because you have you have this little helper there that says he's allowed to do the dumb things, but
Yeah.
it helps to discuss and helps to ask questions about the domain that we're trying to get through.
Yeah, because it has so much of memory, so much of
Yeah,
content from everywhere, it can generate so many combinations for you. And
yeah.
from that combination, you can checklist. Yeah,
It's
just to touch base what you mentioned, right? That basically at lower level, we are doing the same thing. And all of
yeah,
us, somehow we are not on the same page,
right.
right? Thanks to LinkedIn. But yeah.
Yeah.
Okay. Thank you
Thank
so
you.
much, Marco. Pleasure.
Thank you.
More things. Thank you. Have a nice day. Take care.
Thank you.
Bye
You
bye.
too. Bye bye.